This video is going to show you two examples of how to solve problems by ratios using Newton's second law. Problem number one. A runner is competing in a piggyback race with his friends. He's applying an unbalanced force as he accelerates from rest. The runner drops his passenger from his back and now moves with the same force as before, but 1.5 times his earlier acceleration. By what factor did his mass change when he shed his passenger? One of the key things looking at these types of problems is you're not really given numbers, you're given factors of change, like something is doubled, tripled, halved, something of that nature, and that's how you know to use a ratio problem. So in order to use this problem, I've got to figure out which formula to use. Well, it's kind of easy right now, but normally what I would do is I'd list my givens. So I'll start by listing the givens, and I've got the force is not altered, the mass is changed, and the acceleration is altered. And that tells me to use F equals ma. So right now it's kind of simple, but later on we'll have more formulas and we'll have more choices. To find a ratio problem, what I'll do is I'll set it up like this, with the new formula with factors of change divided by the old formula. So the old formula is F equals ma because I have force, mass, and acceleration. The new formula is given by the word problem. So the force has the same force, so it doesn't change. It's 1 times F. The acceleration is 1.5 times the acceleration. That's 1.5 a, and I want to find out what happens to the mass. Now the way the ratio problems work is you divide one formula by the other. So whatever appears in the denominator is wiped out of the numerator. So force is in the denominator and numerator, it goes away. Mass, same thing. Acceleration, same thing. So force divided by force is equal to 1. So 1 is equal to x times 1.5. Solve for x, and I get 0.6 repeating. So the new mass is 0.6 times the old mass. Remember, when you're stating an answer, you have to state it as a sentence. All right, let's look at a second example problem. A truck is moving down the road when an alien ray changes its mass by a factor of 2.4, and the truck responds by producing an acceleration that changes by a factor of 0.6. By what factor of change did the truck's force change? If the truck's original force was 9,000 newtons, then what's the truck's new force after the alien ray? So two questions. Let's start with the first one, finding that factor of change. I'm given that the force has changed, I'm given that the mass changes, and the acceleration is altered. So that tells me, again, I'm going to use F equals ma. So for all ratio problems, we start with the new formula with factors of change divided by the old formula. So we divide it in this case by F equals ma because I have force, mass, and acceleration that are involved in the problem. In the numerator, if I look at it, I know the mass changed by a factor of 2.4. And if I read through the problem, I can also see that the acceleration changed by a factor of 0.6. And I want to know what happened to the force. So like variables divide out, so the f's divide out, the m's divide out, and the a's divide out. So now my equation is x is equal to 2.4 times 0.6. X is equal to 1.44, so the new force is 1.44 times the old force, stated correctly as a sentence. The second part of the question said, what's the new force going to be if the old force was 9,000 newtons? So I'll use this answer to find that's answer to the second question. So the new force is equal to 1.44 times the old force. So the new force is 1.44 times 9,000. So the new force is 12,960.